Hey, Crazy Gamer fans, and it's time for another Basics Electronics video following through our book, Make Electronics by Charles Platt. So, here we go. We are doing experiment 3. Let's just flip it open here. And we are doing, this is going to be our first circuit. And I'm going to show you this circuit in two different ways. And for this, you're going to need a 9-volt battery, 3 different resistors, a 470 ohm resistor, a 1K resistor, and a 2.2 kilo ohm resistor. You just need a generic LED, red, green, there's different color LEDs. I'll show you some components in a minute. Some alligator clips, 3 of those, and a multimeter of your choice. This is a fantastic multimeter. It's on Amazon. It's very low priced, and it does just about everything, which we will see shortly. So basically, we are going to learn what a resistor is, how to tell the values of resistors, and then we're going to put different resistors in circuits to see the different reactions of the resistors and how it regulates the current. Wow, that is just messing with the focus. Okay, now let's take a look at some resistors here. Resistors are multicolored. Move this out of the way and we'll bring in the resistors that I have prepared earlier. Swap out the camera a little bit, and then we're going to zoom in here, and hopefully these colors show up. Okay, this here is a metal film resistor, and these have 5 bands on them, but the four of the bands are the ones that tell the different what the value of the resistor is. And then let me show you a carbon film resistor, which uses 3 bands. And that's not going to focus again. Here we go. Oh, there we go. Anyways, it has 3 bands on it to tell its different colors. So we have a 470 ohm resistor, which if we look at the 4 main bands, they're going to be yellow, purple, black, black. The first color is the first digit. The second color is the second digit. The third band is the third digit. And then whatever the fourth color is how many zeros you will add to that resistor. So yellow is 4, purple is 7, and then black is 0. So it is yellow, purple, black, black. So 470 with 0 zeros. Now on a 3-band carbon film resistor, it's going to be yellow, purple, brown. So you have yellow for a 4, purple for a 7, and a brown showing how many zeros, and it's going to be 10. So 470 ohm, 4710. Now if you have a 1000 ohm resistor or 1K resistor, which is another resistor we need, if it has 4 bands, the bands are going to be brown, black, black, brown. So that's a 1, a 0, and a 0, and a 1, so it's 10. So 1, 0, 0, 1, 0, 1000 ohms. On a 3-band carbon film resistor, it's going to be brown, black, red, which is 1, 0, and then red is 2, so it'd be 2 zeros. So it'd be 1000 ohms or 1K. And for 2.2K or 2200 ohms, on a 4-band would be red, red, black, brown. Red for 2, black is 0, and then 1, 0. And then on the 3-band is going to be red, 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 2, 2, and 2 zeros. I do not like these metal film 5-band resistors. very complicated and hard to read. These four total bands on the, with only three telling you the value, are better for reading. And on these resistors, I'm going to show you in the book here. You can see that these are the carbon film. There's the three bands, and then there's a band, either gold or silver. It can be different colors. That is the tolerance of the resistor. Silver is going to be a 10% accuracy, and a gold is going to be a 5% accuracy. When you pick up a resistor, if you make it so that the gold or silver is on your right hand side, if you're looking at it, the bands on the go starting from the left, like you read from a book, will tell you the colors you need to know. And then here's a good example of what all the numbers are. You got black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, purple is 6, pink is 7, no, blue is 6, pink purple is 7, gray is 8, and white is 9. And then now we're going to talk about some LEDs. So let's see if we can do that here. So this is an LED, and it has two legs. It has a long leg and a short leg. The long leg is generally your positive, and the short leg is generally your negative. And if you look very closely on the short side, you can see a flat section on the LED. And it has a flat side that's going to be your negative side. But let me show you on a clear LED something on the inside. If you look inside this clear LED, I can get it to focus. You can see the larger section, that is going to be your negative, and then the smaller section is going to be your positive. The LED chip actually sits on top of this larger section, this anvil section, and then a gold jumper wire jumps over to the smaller section, which is your positive. As you can see, the longer leg and the shorter leg on this square rectangular LED. So that's basically LEDs in a nutshell. So we are going to connect up this circuit, and we're going to take our 9-volt battery here, and I have this two different ways. So this snap comes with the kit. The snap comes with the kit. We're going to snap it on our battery, and then we know that the red is your positive and the black is your negative. So we're going to connect the red alligator clip, hopefully, to the positive, and then now what we're going to do is we're going to start with our 2K resistor right here. If you have a carbon film, it's going to be red, red, red. This is 2.2K or 2,200 ohms, and we're going to connect it to our negative side, and then we are going to connect our yellow jumper from there to the short leg of the LED like that. And then when we touch the red lead to the long positive lead, the LED lights. And that is basically this circuit. And then what we can do is leave that there to glow, and then we can put in a 1K resistor, which would be on a 4-band with the 3 read would be brown, black, red. And we will put that in series. and it glows a little bit brighter. So that would be with 1,000 ohms. And now let us take a look with the 470 ohm, which would be yellow, purple, brown. And I believe that was too much current. We blew the LED. Oh, nope, it wasn't. Is this resistor bad? Huh. But, okay, so now we're going to move on. We're going to find out what's wrong with this resistor. This happens, and you need to troubleshoot the circuit. I know the LED's good, so let us take a look at this resistor. So we're going to bring our meter here, and we're going to switch it to ohms. And we're going to measure the resistance of this resistor. And it is, wow, this one's 470 kilo ohms. So it was definitely mislabeled. So let's see if this one is 470. Yeah, that one was definitely mislabeled. That happens. You buy cheap electronics, they get mislabeled. So there's a 470. But you know, that's a good lesson there. 470,000 ohms would definitely not light the LED. So let us put in the 470 and we'll see how bright it gets. And then see how bright it gets there. Now what we can do is we can do these same experiments and we can measure the current running through the LED. So we're going to unclip the yellow and clip the positive of our meter. And you want to make sure on your meter you put it in the amp section. This one's for milliamps because we're only going to be doing milliamps. And you turn your meter on, and then we are going to take the black and we're going to connect it to the red, which is the 2,200. And then we're going to connect it to the black of our meter, and that will be in series. And we are with 2,200 ohms, we are passing 3.3 milliamps through that LED. Now, an LED has a forward voltage, this one particularly, about 2 volts. And that means we're dropping 5 volts plus across this resistor. It's not really getting warm, but we might be exceeding the power rating of this resistor. Let's see. So that's that. Now let's try it with the 1K, and we'll see what we get in value. And now we're drawing 7 milliamps, so it's getting a little bit more current. Now let's try the 470. Now we're getting about 14 milliamps. Now this is about where you want to run an LED for the life expectancy of an LED. They can take up to 20 milliamps before they start taking damage, but they are plenty bright at 15, 17 milliamps. So this would be a good point to run them at. You could even go down to probably a 430 ohm resistor. Some people say 220 ohms, but I only recommend that on a 5 volt supply, not a 9 volt supply. So now what I'm going to do is I'm going to disconnect this, turn my meter off, switch back my probes, because you don't want to leave it in the amp section, because if you go to test something and it's in the amps, you'll be putting a dead short across your circuit. So we're gonna take away the messiness, and I'm going to show you how you can do this on a breadboard. So let us take a look at this right here. This is a breadboard. We're going to learn more about these in future videos, but basically I have a 9-volt battery with a jack on it and a jack plug that plugs into my breadboard to power up the rails. And now we have our LED, and we can just put our different resistors in by plugging them in here. So I'm going to take this 2.2K, stick it in the slot, and boom, I did that. Let's swap another resistor. Let's do the 1K resistor, and we're just going to put that in series to the negative. See, it's a little bit brighter. And then we're going to do the 470. This is one of the metal film with the more bands on it. And it's about at its peak brightness. And you can still test, current and voltage and things like that while it's in one of these breadboards. But it's just a lot neater, and it's just a nicer way to build the circuits. You have your power rails, and then these are all connected vertically. Like these are all vertical, these are all vertical, and these are all horizontal. There's a negative and a positive line. But we'll go more in that the next chapter or the chapter after that. So that is this circuit. Let's go ahead and shut that down and let us review what's in the book. So we went over showing you how to test a resistor if you read it and it's wrong, like that resistor was a 470K and not a 470, it's mislabeled. So I was able just to put my meter on the ohms and then put it across the resistor. It was able to tell me how many ohms the resistor was. The book also has some interesting stuff about the numbers for resistors. That's a good read. It's interesting. The end of the thing on cleanup, you can still use the battery and LEDs in the next experiments, and the resistors can also be reused. They weren't damaged. Nothing was really damaged in this circuit. So next is going to be experiment 4, and it's going to be variable resistance. And for that, you're going to need a 9-volt battery, a 470 ohm resistor, and a 1K resistor. Use the ones from the previous experiment. 2 generic LEDs, which I already have 2 out. I have a red and a green. You're going to need 4 of the alligator test clips. You're going to need 4 of these alligator clips, or a breadboard with some jumper wires. I'll show you both ways. You're going to need a potentiometer, a linear 1K potentiometer. This is a potentiometer right here. It turns and it varies the resistance. And you can look on there. Let's see if we can get this into focus. There we go. Well, you can see this is B2K. This is a 2K potentiometer. So that's basically that. All right. So, and then, of course, your multimeter flavor of choice. So that's going to be it for this video. For Crazy Gamers Games, I hope you enjoyed this basic tutorial on electronics. Stay tuned for future videos. You all have a great day.